Okay, so today what we're going to look at is a continuation of last time. We're still on section 8.2, but we're going to practice doing a few things. One, we're going to practice going from what we call vertex form, because when you look at it, you can see the vertex, and then going to standard form, right? Notice they're different. Notice A is the same value that you always see first. In vertex and in standard form, and that has to do with up down direction and how narrow or wide your graph is compared to the parent. But just make note that, for example, in vertex form, that next variable we see is h, versus over here in front of the x, the coefficient is b, and the last letter is k versus c. And you just use different variables because they do different things based on the form, okay, that you're in. So I'm going to show you later how to go from this form down to this form. Well, actually, we can look at this first one. So a lot of people sometimes forget they want to distribute first. PEMDAS, right? You can't simplify inside the parentheses, but you need to do squared. It's not x squared plus 9. It's x plus 3 times x plus 3. So if you take x plus 3, right, and you multiply again by x plus 3, you distribute, and when you distribute all terms, you get x squared plus 3x plus 3x plus 9. And when you simplify, you get x squared plus 6x plus 9, which is right here. And you leave that inside of parentheses. And then, right, so you did this exponent first. X plus 3 times x plus 3 is x squared plus 6x plus 9. And then you distribute in the 2. So in PEMDAS, then it's multiplication. So you got 2x squared, 2 times 6x is 12x, 2 times 9 is 18. And then you had this negative 22 hanging outside. Then again, you simplify, combine like terms. So you have positive 18 and negative 22. So you get negative 4. Now we have the same equation, just looks different because it's in standard form. A would be 2, B is 12, and C is negative 4. So they're the same equation, they're just written in different ways. Okay. Now what we're going to do next, these are the same problems as last time, but we're going to practice some different stuff, okay? So going off the equations we had last time for 29, right, we did the odds, and then you guys did the evens, practicing vertex, axis of symmetry, up, down, narrow or wide compared to parent. The stuff in yellow stuff we already did, so I just copied that from before, okay? But as a reminder, to find the vertex, I like to say opposite of inside. I say inside meaning parentheses. Opposite of inside, which would be negative 1, comma, number on the right, 4. And that's your vertex. That's one of the reasons why we call this vertex form. You look at it, you don't have to plug into a formula. You just say opposite of inside, so negative 1, comma, 4. That's your vertex. We'll come back to that. Look at the next one. Opposite of inside, so opposite of negative 5 is 5, comma, number on the right. It's called vertex form because you look at it and you see the vertex. Let's look at 33. Opposite of inside would be 1, comma, number on right, 4. You see the vertex when you look at it. Then 35. Opposite of inside would be negative 2, comma, number on right is 2. It's in vertex form, so you look at it and you see the vertex. And if we go back up to the top, notice again that the axis of symmetry is again the x-coordinate of the vertex. Oops, and I screwed this up. So the x-coordinate of the vertex is negative 1. So that's why the axis of symmetry is x equals negative 1. I put the vertex in the center of your table. Okay, let's look at the next one. If the vertex was 5, 6, your axis of symmetry, it's the x-coordinate of your vertex. I also put the vertex in the center of my table. The axis of symmetry, remember axis of symmetry is that vertical line that slices through our graph, goes through your vertex. So it's the x-coordinate of your vertex. So it's x equal 1. I put my vertex in the center of my table before I start to find other ordered pairs. Lastly, 35, our axis of symmetry is x equals -2. Oops. X equals -2, and I'm going to put my vertex center of my table. Okay, so we did all that last time. Now let's find ordered pairs. So when we look at this, I want to pick, just like before, I want to pick some values above and below my graph. Okay, and I'm going to see. Okay, so let's use a different color. So let's pick, no. Okay, let's pick a different color. So let's do blue. Let's pick a value that 2 that are less than -1, right? We're plugging in x values, and then we're going to do 2 that are more. So if I had a number line, right, I know that, I know that 0 is on the right, and then I'll do 1. 1 unit to the left of -1 would be -2. Another unit away would be -3. I picked those because, remember, if stuff's equidistant x values from the vertex x, then the y values will be the same. So I know that if -2 and 0 on the number line, if I know that -2 and 0 are a unit away on the number line, what the heck? Then their y values will be the same. So I'm just going to plug in one of them. Now you need to be careful. If I plug in 0, it doesn't just become 4. Okay, so let's plug this in. If I'll practice function notation. So f of 0, that means I'm going to plug in 0, is equal to 2 times 0 plus 1 squared plus 4. Now inside we get 0 plus 1 is 1. We're just doing order of operations. Be careful with your order of operations. Next we do 1 squared is 1. And 2 times 1 is 2. And 2 plus 4 is 6. Now I know that -2 will also be 6 because they're going to be the same value because they're equidistant, -2 and 0 from the center, -1. Okay, now let me plug in, Boomer, shh. Let me plug in -3. So if I plug in -3, I'll just use y now. Y equals 2 times -3 plus 1 squared plus 4. So we have 2, in parentheses, we get -2 squared plus 4. Exponents, so we do -2 times -2, which is 4. And then we have 8 plus 4, which is 12. So we'll come up here, we'll write 12. We'll write 12, and now let's go to graph. So I'm going to do -1, 4, -1, 4. I'll do a dot there. I'll do a dot at -2, 6. So -2, 6 is right about there. I'll do a dot at 0, 6. I'll do a dot at 1, 12. So it's a little bit above here, right? And at -3, 12 is up there. Okay, I like to start at my vertex and then go out and make a nice U shape. U shape and arrows. Okay, and then lastly, let's write this in standard form. Okay, let's take this equation and write in standard form. So if we do this, we would have 2y equals 2. I'm going to write x plus 1 2 times. Oops. Okay, now I'm going to multiply x plus 1 times x plus 1. If you FOIL x plus 1 times x plus 1, you'll end up with x squared plus 2x plus 1. We'll leave that inside parentheses. Now we'll distribute in the 2. So we'll get, so it becomes 2x squared plus 4x plus 2 plus 4 y equals. So then we would have y equals 2x squared plus 4x plus 6. So that is the same equation, it's just written in standard form. Y equals ax squared plus bx plus c. Okay? Vertex form, when you look at it, you can see the vertex. Vertex is opposite of inside number on right, -1, 4, which helps you. Standard form, ax squared plus bx plus c. A is 2, b is 4, c is 6. It's nice when you see it in that form, right? Because you can see your y-intercept, 0, c or 0, 6. To find the vertex, you would have to do -b over 2a, right? Find that value, plug it back in. So it just depends on what form you're given and how you want to proceed. Okay, I'm going to stop here and then we'll do the next video.